Okay, 3.7 notes. We're talking about perpendicular lines and proofs as to when two lines that cross are perpendicular. So we've done perpendicular bisectors in Unit 1. Perpendicular bisectors. So perpendicular means and we use this sign, looks like an upside down T, means 90-degree right angles, right? And bisector means half, cut in half, two equal parts. All right, so when we have perpendicular bisector together, it has to cut a line segment in half and make a right angle. So when you look at number 1, or when you look at A, it is not a perpendicular bisector because it's not perpendicular lines. They do not make 90-degree angles. B is a 90-degree angle, but these two guys are not the same. So, yes, perpendicular, not bisecting, not half. And it's pretty obvious. Okay, and then the last one's going to be yes. I see a right angle. And I see, well, I'll just write it this way, EF cut in half. Because the two segments are equal to each other, which is what those lines mean. Okay. So, the shortest distance from a point to a line is always perpendicular. Because that's the fastest way you could get somewhere if you were going that way. Okay, so we're going to do some exploring and we're going to write some postulates that we can use for proofs. So, first thing we're going to do, and you should pause and try and do it, draw two parallel lines. Label them A and B. Now, I'm going to draw a line C parallel to B. Okay, what do you notice about A and C? They are also parallel. And when we're doing parallel, which we did in our last lesson, we just draw two kind of long lines together. I usually make mine up and down. You could do more that way if you wanted to. Okay, so kind of a transitive thing here. If we drew A parallel to B and B parallel to C, then kind of by our transitive property, because these are parallel, then we can say A is parallel to C. And that is our shorthand. I guess we could have written it out. But here it is all written out right here. If two lines are parallel and a third is parallel to one of them, it's also parallel to the other. So this kind of is I already wrote it in a shorthand, I guess. All right, now let's do another drawing. let's draw two lines that are perpendicular. Okay, and one is R and one is S. Now we're going to draw a line T perpendicular to line S. So T is going to go this way. All right, so R and T are parallel. If two lines are perpendicular to the same line, they're parallel to each other. So, oh, her picture looks totally different than mine. Okay, so we are given R is perpendicular to S, and we are given that T is perpendicular to S. So then R is perpendicular to T. These are kind of easy, but like once there are those things that once you prove them, then you can use that in other proofs. All right, so I'm going to draw N and P parallel. So this is N and P. So I'm going to draw Q perpendicular to N. Oh, I should have done it in a different color like I was doing a minute ago. All right, so it's perpendicular to N. It's also perpendicular to the other. So if we know that N is parallel to P and Q is perpendicular to N, then Q is perpendicular to P. All right. So let's draw a linear pair. I mean, it's a straight line whose angles are congruent to each other. So I have a linear pair. If I have a linear pair and these guys are equal to each other, then they have to be 90 degrees, which means they have to be perpendicular. Okay, so if I have a linear pair and I have congruent angles, then the two lines are perpendicular. They should have letters. I don't know why they didn't, but there you go. All right, so we're going to use that to prove that R and T are perpendicular. So we know that R is parallel to S. And remember, we use those big arrows on there to show that they're parallel. And we also know that angle 1 is congruent to angle 2. So this one and this one are equal. Okay, so we know those lines are parallel. So that means that corresponding angles of parallel lines are congruent. So these would be corresponding angles. So we're going to have angle 2 is congruent to angle 3. And then, for those of you in my class, my favorite thing is that you can do that, and that is the transitive property. Transitive property. And then, I did not mean to change colors so many times. We have now proven that R is perpendicular to T, and we're going to use the last one, the last exploration that we used. So we're going to use this. So I proved that angle 1 and angle 3 are equal to each other, and they're a linear pair. So that means these have to be 90s, right? So angle 1, angle 2, angle 3 are all 90-degree angles. So two intersecting lines are a linear pair. Of congruent angles. Then two lines are perpendicular.